Hello everyone. Hopefully all is well. This is Dr. Looney. Today I just want to introduce a topic that I have not introduced yet, and this is actually the second fundamental theorem of calculus. So we're going to go ahead and get right into uh, that particular topic today. All right, so basically we have f is a continuous function on an open interval containing a. So a is just some real number that's contained in an open interval. So let's just say if I had the open interval from 1 to 4, we know 1 and 4 is not going to be included in the interval, but your value for 3 could be your value of a. So a is just any real number. So again, we have a continuous function on an open interval containing some real number a, and we're going to define g of x as the integration, and my lower limit is a, and then my upper limit is now actually a function. So do you remember? I don't know if you recall, but with the first fundamental theorem of calculus, we were going from a to b, integrating the area under the curve, and a and b, they were real numbers. But in this case, we're actually integrating from a to some function that's dependent on x. And so, and then we're going to integrate. So our upper limits is going to be from a to h of x, which is a function, but we're integrating the function f, which is dependent on t. So that's the one uh, big difference, that we're not going from A to B. We're going to a number. We're integrating from a number to a function. So this time our limits of integration is going to involve some type of function. All right, and so this says if I take the derivative of that particular, if I take the derivative of g of x, then I'm going to get g prime of x is equal to f of h of x times h prime of x. And that's basically, if you look here, let's go back to the integration. Now, do you see everywhere I have a t, I basically have put the function h of x. So that's where we get f of h of x. And then here where you say, well, this is a d times h of x, but this is really saying take the derivative of h of x, because again, everywhere I see a t, I'm going to replace it with h of x. So I take the derivative of h of x and I just write that as h prime of x, h prime of x. And so now, since we were taking the derivative, well, you know the derivative is going to cancel out the integration, so that's why we no longer have the integration sign when we find g prime of x. All right, so let's go ahead and look at one quick example to just make sure you understand how to at least analytically derive your g prime of x if you're using the second fundamental theorem of calculus. So let's look at this example. We have g of x is equal to the antiderivative, and we're integrating, the integration from 2 to x squared. So we have a real number here, 2, and our upper limit is some function, x squared, and we're integrating the sine function, t dt. So the question is 2 going to be continuous on some open interval for the sine of t? Well, of course it will be, because the sine of t is actually continuous everywhere. So that's just a continuous function. So we know we can use the second fundamental theorem of calculus to find what g prime of x is going to be equal to. So what is g prime of x is going to be equal to? We get rid of the integration sign. Since we're taking the derivative, that's going to cancel out the integration sign, and everywhere we see a t, we're going to put the upper limit, which is x squared. So that's where we get sine of x squared. And then we need to do what? Multiply by the derivative of what's inside the parentheses. And that's going to give us our 2x. And I went ahead and put the 2x in front because that is the most common way to write that expression. So that's basically the second fundamental theorem of calculus. And I'm going to, I created this problem to kind of show you what it would possibly look like on an AP exam. Now, this problem that I created is going to include other things other than the second fundamental theorem of calculus. You know, the unfortunate thing about when you look at these, especially the free response questions, there always are going to be a little bit more detail. So you'll be using multiple topics when answering these particular questions. So that's what I kind of want you to be accustomed to doing. So what this next problem is going to do is going to incorporate the first fundamental theorem of calculus and the second fundamental theorem of calculus. And so let's go ahead and look at that. And I know I don't have to mention this, but I will. At any time, this is a video, so the things that I've already previously went over, if you can always stop the video and go back to those things. All right, so we have g of x is equal to the integration from 0 to x. So now we are integrating from some real number to the function x of f of t dt. And then we have the function f, and you can see that this function f is continuous everywhere because we don't have any holes or jumps. So I know I can use this the second fundamental theorem of calculus and the first fundamental theorem of calculus as well, because when we're finding the area under the curve using the first fundamental theorem of calculus, we need a continuous function. So it's going to work for both of these. So let's go ahead and make sure we emphasize that this function is going to be f. So the graph is a graph of f, but this says g of x is equal to the integration from 0 to x of f of t. So this is not the graph of g, this is the graph of f. All right, so this is what the problem is going to be asking us to do. I have it on a separate page, so I'm going to get that out here. So we're going to be finding g of -1, g of 2, g prime of 4, and g double prime of 3. So let's look at that. Now, remember, we have to use this graph. I'm trying to get this all in on the same page. But we have to use this graph and find these particular things. So right now I'm going to remove the graph and then we'll refer back to it. So let's first find g of -1. So since we know that we are going to have g of -1, now g of x is just equal to what? G of x is equal to the integration from 0 to x of f of t dt. So this is basically saying if I want to find g of -1, everywhere I see an x, I'm going to put a -1. So the only place I see an x is for the upper limit. So I know I'm going to be integrating from 0 to -1, the function f, with respect to t. Now, the problem that we have initially is that we're integrating from a bigger number to a smaller number. So we need to flip our limits of integration to go big, small to big. So when we flip it, we get a negative sign. So now we just want to find the area under the curve f from 0 to -1. So let's look at what that looks like. If you look at the example here, that area is just going to be a triangle. So that's just going to be base times height divided by 2. And so the height of that triangle was 2. The base of that triangle was 1. If I multiply that by 1/2, I get that's going to be 2 times 1/2, which is 1. But remember, I had to change the sign to negative, so that's just g of -1. All right, so now let's try to look at g of 2. Now g of 2 means that I'm now just going to integrate from 0 to 2, right? So let's look at the portion from 0 to 2, what it looks like on the graph. And if you see here from 0 to 2, we have just a fourth of a circle. So this is a fourth of the circle. So I'm going to find the area of the whole circle and just divide it by 4. Well, since the radius is 2, to get the area of the circle, I have to square the radius and multiply it by pi. So that's going to give me 4 pi divided by 4. So g of 2 is just going to be pi. And then next, we're going to find g prime of 4. So when we get ready to find g prime of 4, this is where we actually need to use the second fundamental theorem of calculus, because we have to take the derivative of g of x. Well, if I take the derivative of g of x, I am going to get rid of the integration, and everywhere I see a t, I'm going to put an x. So this gives me g prime of x is actually equal to f of x times x prime, which is just f of x, because the derivative of x is just 1. So I'm really trying to find f of 4, because g prime of 4 is going to actually be equal to f of 4. But if you go back to this graph, you see when x is equal to 4, y is equal to -1. So you know that g prime of 4 is just going to be, that's just going to be -1. All right, and so lastly, we're going to look at g prime of 3. Well, how do you find g prime of 3? Well, we know that g prime of x is f of x, so g double prime of x is going to be equal to f prime of x. So I'm really trying to find f prime of 3, which is just going to be the slope of the tangent line. Well, let's go back and look at the graph. The slope of the tangent line, this graph is, if you look at this line, this is 2 and this is 4, so 3 has to fall between 2 and 4. So we're just looking for the slope of this line. Well, let's just do it. I rise over, I run. We're going to go down how many? Well, if I'm at 0, I'm going to go down to -1. So I'm going down 1. And if I'm at 2, I'm going to run to 4. So I'm going to go down 1 and over 4. So that's just -1/2. So g double prime of 3 is just going to be equal to -1/2. So I know I went through that fairly quickly. So, but again, this is a video. You have the luxury of stopping. You can also, and going back, you can email me. I've also provided you guys with a telephone number where you could either call or text me. I do not care. You can call private, whatever you decide to do. I prefer email. So that's just my preference, but I know sometimes it may get a little bit more detailed with the questions, and you may want to text or you may want to call. That's up to you. I am going to post an assignment on Canvas that is going to be related to this video. That assignment will be due by Thursday, midnight on Thursday. So make sure you get that done. That's going to be April the 2nd, the final day you'll have to do that. If you have any questions, please do not hesitate to ask them. I'm definitely here and available to help you guys out in any way possible. Stop the video, go back over it, email me, answer questions, whatever you need to do. We're going to get it done. I am going to set up a Google, I think it's called Google Meets, where we can all get online as a class and maybe have discussions if you need to have them over these particular problems. All right, thank you guys. Again, hopefully all is well, and I'm wishing you the best of luck. Have a wonderful day.